Good afternoon, my friend. MoNaCo here.
And Milks.
Listening to your feedback, we're keeping it rolling with the 2 people, 1 video. It's great. We're talking about atomic theory still, and we're working on pages 12 through 13 in your packet. We're talking about different types of ions an atom can become, and how to calculate the number of subatomic particles in any atom or ion. That's the main point of what we're doing today. So let's move on to page 12.
Sweet. Neutral atoms, by definition. An atom with the same number of protons and electrons, the pluses and the minuses cancel each other out. But if it is a neutral atom, P will equal E. The number of protons will equal the number of electrons. So in this case, I see I have carbon 12, and up in the upper right-hand corner, there is nothing in here. It's a neutral atom. No charge indicated. That's how I'm going to draw it.
The types of anions, there's 2. The first one is an anion. It's got the letter N in it. It means an atom has gained 1 or more electrons. That means that the electrons are greater than the protons. N for negative, because if I have an ion written like this, the top left corner is the mass of the atom, the bottom left corner is the charge in the nucleus of the atom. The top right here, you see there's a -1. So it's a negative ion in this case. So we've got, that means the -1 makes a negative charge. It's gained an electron. Okay, so Mr. Milks, take it away.
Wait, no, Mr. MoNaCo, real quick.
What?
Why is the N capitalized there in anion?
Because it's for the negative charge.
Oh, so you're saying that's a way for me to remember that?
Yeah, it's kind of like a mnemonic device.
Nice.
Okay, so let's work on to a cation.
Cation is an atom that has lost 1 or more electrons. In this case, the number of protons will be greater than the number of electrons. Here you see that I have a positive charge 1 on the upper right-hand corner of my lithium. That means the +1 indicates a positive charge. I have lost 1 electron, not 2 or 3.
So like the hardest part for all my students ever with this positive and negative ion is that if you've gained electrons, you become more negative.
Right, and that seems backwards, doesn't it?
It does, but that's because the electron has a negative sign for its charge.
Right.
That's the part that everybody gets messed up. So I gained electrons, I should be positive. No, you gained a negative charge.
Right.
You're now more negative.
Right. Back in the day, I gained college debt.
Yeah.
My bank account
which means
became more
negative money. Yeah, negative money.
Seriously.
Okay, so let's move on here a little bit.
All right, cool.
Let's look at some chemical symbols and the ions. So we have protons of 12.
Yep, so we're going to start with 12 protons. Let's look at our periodic table. Find the atomic number 12 so we can figure out who we are.
Atomic number 12 is magnesium, so we wrote the Mg. And then we put in what we see on our periodic table. Magnesium has a mass 24 and a charge of 12 protons. Okay. And the ion charge is going to be equal to the protons minus electrons. So we're going to take 12 minus 10, because we were told that there's 10 electrons in this particular example. So the charge for this ion that's going to go in the top right corner there is positive 2, because I took the protons and subtracted my electrons from it. Again, it gave me 12 protons and 10 electrons. That's where our numbers there came from. Okay, so now Mr. Milks will do the second one.
All right, I got 72 protons. I got 68 electrons. I look up 74 protons is W.
Tungsten.
Tungsten. And I see that W has 74 protons and an atomic mass of 184, so we want to get in the habit of doing this kind of religiously. Same equation, protons minus electrons. I got 74 minus 68 equals a positive 6. Up in the top right corner. Now remember, when I do protons minus electrons, because it's subtraction, it's a negative, the order is very specific. We do it proper, and we're going to get the right charge in front of our number.
Yeah.
We got to do it in the right order.
Mm-hmm. So now we're doing the same example again, but 95 protons, 89 electrons. I found my atomic symbol is, let's see, Am for americium. And so I found that it's got 95 protons, a total mass of 243. I do my equation for the ion charge, protons minus electrons. 95 protons from the problem minus the 89 electrons from the problem gives me a total of a charge of positive 6. So there are 6 more protons than electrons. So we put that up in the top right corner for americium. Okay. Last example, take it away, Mr. Milks.
33 protons. AS, is it astatine?
Arsenic.
Arsenic. I get those two confused all the time.
I think so, yeah.
Okay. But I have 33 protons, so I'm going to have an atomic number of 33. I got a mass of 75 I get from my periodic table. Again, same equation. And notice this time I have more electrons than protons. So when I subtract them, I get a negative number. So now my charge is going to go up as a negative.
Which really means what? Negative 3. What does that mean?
It means I have 3 more electrons than I have protons.
Okay, so the negative means there's electrons, and the 3 means there's 3 of them.
Right, well remember, the charge on an electron is negative.
Right, I keep forgetting that.
Right, but so if I have a charge up there as of negative, that means I have more electrons.
Good.
Absolutely.
And if it's positive, I must have more
protons.
Okay, got it.
Hey, and P, protons and
P for positive protons.
Yeah, there you go.
Yeah,
so at least we got that going for us.
Okay, cool. So now we're going to do some protons, neutrons, electrons for the following ions. So we already know the ion charge. So for protons, we look up the atomic number for copper, and that's 29. So that's pretty easy. To figure out neutrons, we take the mass of the copper and take away its atomic number. And on copper's, the mass was about 64 minus 29. So we find out the number of neutrons is 35. 64 minus 29, 35. Now to figure out the electrons, we're going to use that same protons minus electrons equation, but in this case, we know that we have positive 2 charge, so we're going to kind of change it. The protons minus the charge equals the number of electrons. So 29 minus 2 equals 24. Oops. Change it. The 29 minus 2 is 27. 7. So don't write 24 in your notes there. That's a typo. Write 27. Now,
see if you're listening.
Yeah. Oh, yeah. We're going to see if you're listening. Now, the next one Mr. Milks will do.
All right, lithium. I look up lithium. The atomic number of lithium is
3.
a whopping 3. To calculate my neutrons, again, I'm going to do my mass minus my atomic number, and my mass should be about 7. Remember, I'm going to take that 6.9 and round it up to a whole number.
Yeah.
7 minus 3, of course, is 4.
Now to find the
Got this
electrons.
one right. I'm going to, again, do protons minus the charge. So I just manipulated that equation with a little algebra. Same equation, I just, what I do to one side, I do to the other, so I can get electrons by itself, because I know protons,
charge
I know
equals
charge.
protons minus electrons, so electron equals protons minus charge.
Right.
Got it.
Same.
So,
It's the same equation.
3.
So now 3 minus 1 is?
Wait. Where'd the 1 come? I see in the symbol up here, I just see a plus.
Oh, well, I guess that doesn't go without saying now yet, does it? Whenever I see in chemistry no number, it's assumed 1.
Oh, you mean kind of like no number in front of x in an algebra equation?
Exactly.
So if I see x by itself, it means 1x.
Right.
If I see a plus by itself, it means what?
Plus 1.
If I see a negative by itself, it means what?
Negative 1.
Got it. Okay. If there's no
Great
number
point,
written, it's
Mr.
got to be
MoNaCo.
1. It's
That's
got to be
great.
1.
So, of course, 3 minus 1 is
2 electrons.
So I need 2 electrons, so I have 1 less electrons than protons to give me that positive charge.
Okay. Let's look at protons, neutrons, and electrons for an oxygen anion. Use the term negative ion.
Ooh,
Cool.
anion.
Atomic number is 8 for oxygen. And the number of neutrons is mass minus atomic number. On the periodic table, mass is 16. So 16 minus 8 is, 8 neutrons. So I got 8 protons, 8 neutrons. And my electrons equals my protons minus my charge. So protons would be 8 minus negative 2. If I subtract the negative 2, it's like double negative. Oh, it's a positive.
It's like adding, right?
Right, it's like adding 2. So that's really 10 electrons. So there's more electrons than protons, which is why there's a negative charge. So for these last 3, I would like you to follow our examples and kind of do them on your own. Because, Mr. Milks and I here, we're running out of time. We don't want this to be a 30-minute video. We're going to move on.
Right.
And we're going to have you see what is up.
In case,
Oopsies.
in case you don't have your periodic table handy, the atomic number of chlorine is 17.
Cool. 17 for
Right.
atomic number there.
Yep. Its mass is 35.
Okay.
So I'm going to say 35 minus 17
Cool.
is 18.
Right.
Right.
And the electrons?
All right, so I have my protons minus my charge.
which is a negative this time.
Right, so it's 17
minus negative 1. Right?
Yeah.
Okay,
That's
I got
gonna,
it.
Yeah, and that's going to equal 18.
18. Next example. We're not writing these down because you got to be listening. All right, my atomic number for aluminum is 13. Okay, my mass is going to be 27 minus 13 for my number of neutrons. And my electrons is going to be protons, which is 13 minus 3. So 10 would be my answer for my electrons there. Last example I'll run through real quick while Mr. Milks is busy here. My protons for iodine. My protons for iodine is 53. That's the same as the atomic number. My neutrons is going to be mass number 127 minus 53 here for a total of 74. And my electrons is going to be my protons, 53, minus the charge here, which is 7, equals 46. Okay, so there's the first proof to see if you're actually listening to us. Keeping it rolling.
All right, so again, same game. I see now. I'm going to mix in. If you look, I have positive charges, I have negative charges, and I have 0 neutral charges. So now this is the whole game, all in one big
In a chart.
right, and just in a chart form. So same game, just in a chart. So
Right.
let's go with what we know. Lithium, 3 protons. So right away I know that I have 3 as far as my atomic number because my number of protons and my atomic number are synonymous, which means they
The
mean
same
the same
thing.
right? So to figure out my number of electrons, again, protons minus charge, it's going to be, so it's going to be
Protons,
3 minus 1,
minus 1 is 2.
done. Mass number, add up my protons and my neutrons,
4 plus 3 is
7.
7. Okay, cool. So we're moving on to the next one. Phosphorus, 3 negative. So the first thing we got to do is look up the atomic number for phosphorus, P, on the
15.
periodic table. 15 is the atomic number. So then I can know immediately if the atomic number is 15, my protons also has to be 15. So now I'm going to look at my number of neutrons. So, okay, I got my mass is 31 and my atomic number is 15. So I'm going to say 31 minus 15.
Wait, do we have an equation for neutrons, Mr. MoNaCo?
Yeah, mass minus protons.
Oh, I didn't have that written before.
No,
How'd you get that?
Well, because the atomic mass equals protons plus neutrons, I rearranged it. If
Oh,
mass equals
yeah.
protons plus neutrons, and I wanted
So
neutrons
I rearranged
by
that
themselves.
other equation so I can rearrange this equation if
You can
it suits
rearrange
my needs.
any equation if you know your
Oh.
algebra.
Thank you for your permission.
So 31 minus 15 is 16 there. So off to vanadium with no charge.
All right, so this is a neutral atom. I'm going to start. I see my atomic number is 23. So if my atomic number is 23, I know my protons number is 23. After that, I can do electrons. I say protons minus my charge is, of course, this is going to be 23 minus 20. Okay, it's going to be 0, or 23 minus 0 is going to be, of course, 23. Because remember before we said on a neutral atom, protons equal your electrons. For a neutral atom, neutrons, I got to manipulate my mass. 51 minus 23 is going to be 28. So there we go.
Okay, let's zip through the last few here. Krypton. Krypton is a special situation. You want to take your number of protons is the same as your atomic number, so it's 36. Okay, and again, I'm reading these to you. You got to listen. I'm not writing it on the screen. It's 36 protons. So then I'm going to figure out from my protons and my electrons that the charge is 0, so the protons equals the electrons. So there's also 36 electrons. And then the last part, I got to add my number of protons and neutrons together. 36 plus 48 is 84 for the mass on Krypton. So Mr. Milks is here for barium,
So,
positive
as a
4.
matter of fact, this is where you can hit pause and finish these next two.
And then
How about
see
we do
if
that?
you're right.
And then we'll give you the answers and see if you're right. How's that even sound? Better?
Sounds great. So
All right,
pause
cool.
it.
All right, unpause
Thanks for
it.
pausing it. Okay.
All right, so I see barium. I have 56 protons, so my atomic number must, of course, be 56. To solve for electrons, it's going to be protons minus charge. So I'm going to do 56 minus 4 is 52.
Yep.
And then my neutrons, I have to rearrange my mass equation. It's going to be my mass, 137, minus my 56 to give me 81.
neutron.
All right, what about uranium, Mr. MoNaCo?
Uranium. Why are you talking about my uranium over there? That's not right.
I can just read. I don't spell well, but I can read.
You can read. So the thing we start out here with, this is a tough one. This is a real challenge because we're starting with electrons and neutrons and we're working backwards. So I look up on the periodic table. I'm going to look up my number of protons and atomic number. I see that it's both of them is 92. Okay? So now all of a sudden, atomic number and protons is 92. So now all I have to really figure out is mass. So it looked like a scary problem. But then I used my reference table, and 2 of the 3 things are filled out.
You used your tools?
My tools.
Good job.
I am not a tool. I use my tools.
That's right.
And then found the mass by taking my neutrons and adding it to my protons. So 146 plus 92 equals 238. And there you have it. That is our longest video. But
sorry about that.
2 kinds of ions, anions and cations. The definitions of atomic number, atomic mass, and charge. You got to know these things, and you got to know how to do subatomic particle calculations in any atom or ion, positive, negative, or neutral. Got to do it.
The biggest hang-up, guys, is that charge on an electron is -1,
and
so the charge gets more negative when I add.
And you got to memorize those secret little equations that don't exist in our reference table.
This is
protons
true.
minus charge, etc. So this was a long video. Thank you for watching. Watch it again if you don't understand it, because we got like many pages of practice to do. I've counted at least 3 or 4.
Right. Feel free to go ahead and get working on those if you're confident.
Thanks for watching. Bye.